Well, welcome back. We are going to continue on in Chapter 4 with talking about using corresponding parts of congruent triangles. And so far we've learned 4 different congruence theorems for our triangles to prove that they are congruent. And each of those 4 triangle congruence theorems uses 3 pieces of information. So we have side, 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 angle, angle, and angle, angle, side. And so that's going to help us. Once we know that some triangles are congruent, we can say that all of the corresponding parts then are congruent. So our focus question is, what is useful about proving triangles are congruent? And we will answer that by the end of the lesson. So let's jump right in. Here's a problem. And we are given 2 triangles, triangle KBC and ACB. And we want to prove that segment KB right here is congruent to AC on the other side. So we're given 2 pieces of information. Angle KBC, so that's the one with the single arc here, is congruent to angle ACB, that's the one with the arc here, and angle K is congruent to angle A. So those are our 2 given statements, so that's where we're going to begin with our given statements. Well, we only need one more piece of information to prove that the triangles are congruent. And that is a side. We have 2 angles here. So if we can get a side, either angle, side, angle, or angle, angle, side, we can prove that those are congruent. Well, by now you should be able to see that if we just say BC is congruent to itself, since that is shared by both triangles, that would be the reflexive property of congruence. And so now we could say that triangle KBC is congruent to triangle ACB, and that would be angle, angle, side is our theorem. So we can now say that side KB right here is congruent to side AC, and our reasoning for that is going to be corresponding parts of congruent triangles are congruent. Okay, that CPCTC stands for corresponding parts of congruent triangles are congruent, and I highlighted that in the last slide right here. I underlined that. Corresponding parts of congruent triangles are congruent. That's the CPCTC. If you want to abbreviate that, then we don't have to write that out every time. So that's kind of where we're headed. Let's take a look at a couple more examples. I'll do the got it one for you, and then I'll have you pause the video for the second one and see if you can try that one on your own. So on this one, we are given that side BA, right here, BA, segment BA is congruent to DA. We have that marked. And it says side CA is congruent to EA. We also have that marked. So we have 2 sides that are congruent. We want to prove that angle C is congruent to angle E. Well, we can prove those are congruent. If we can get the triangles congruent, then we can say that the parts are congruent. So we start with our given statements. I've got that here. What would be the next statement that we could say? Is there anything else we could say is congruent? Well, you should recognize by now also that this angle here, angle CAB, is congruent to angle EAD. What's our reasoning for that? Why would angle CAB be congruent to angle EAD? Be very careful to get the order of your letters right, that they're the corresponding parts. Well, those are vertical angles, right? And all vertical angles are congruent, so you can just write vertical angles. So now we have 3 pieces of information, right? So we can say triangle CAB is congruent to triangle, let's see, that would be DEA, right? Or wait, CAB, EAD, excuse me, EAD. Why do we know that that's true? Well, we have side, angle, side, right? So that's the side, angle, side triangle congruence theorem. So now we can say what we were trying to prove. Therefore, angle C is congruent to angle E. And if you look at our congruence statement here, I'll choose a different color to highlight this. Angle C should be congruent to angle E because corresponding parts, CPCTC, corresponding parts of congruent triangles are congruent. Okay, let's go ahead and look at the second one. Go ahead and pause your video and see if you can work on this one on your own, and I'll give you the solution when you get back. All right, hope you took some time to do that one. I have you started here with your given statement. It says that side AB is congruent to side AC, and those are indicated in the figure as being congruent. They also tell us M is the midpoint of BC. Well, what does it mean to be a midpoint? If M is the midpoint, then we know that the distance from B to M is congruent to the distance from C to M. So we can make that statement. We can say side BM is congruent to side CM. What would our reasoning be for that? Why would that be true? What piece of information did we use to come to that conclusion? And that would be the definition of a midpoint. Hope you can read my shorthand here. Okay, so now we have two sides that are congruent. Is there any other information that we can use from the figure? And always look for sides that they have in common, and that's usually a freebie. So we can see that side AM is congruent to side AM. We can say that it's congruent to itself. And what property is that? Do you remember what property that would be? Side AM is congruent to side AM. And whenever we have something congruent to itself, that's called the reflexive property. Okay, so now we have all of the sides are congruent, so we can say, therefore, triangle AMB is congruent to triangle AMC. And what's our reason? Well, we just said we have all three sides, so that would be the side, side, side triangle congruence theorem. So lastly, we can say what we were trying to say. We were trying to prove that angle AMB is congruent to angle AMC, and our reasoning will be corresponding parts of congruent triangles are congruent. CPCTC. All right, here's your lesson check for you. Go ahead and work on these on your own and bring your answers to class. We'll see you next time.